Hello, this is Ms. Walsh, and today we're going to take a look at zero and negative exponents. So we're going to start with the zero exponent. All right, so here we have x to the m divided by x to the m. We're going to use the rule from the previous podcast where if we have the same base, what we do with the exponents is we just subtract them. So this can be rewritten as m minus m. Well, m minus m is just 0. So the answer to this is x to the power of 0. Now let's take a look at a slightly different way of writing it. So if you have x to the m divided by x to the m, this is exactly the same term, right? This is no different than 5 divided by 5. Well, you would just cancel that and make it a 1. And so same with this. This would just cancel and then it would just be 1. What do we see? These are the same terms, so these must be equivalent answers, okay? So we can see that when you have the base to the power of anything, it means everything canceled, and then your answer is just 1. Okay, so now let's extend that to negative exponents. Okay, so I'm going to use the subtraction rule again. And here we're going to have x 2 minus 3, which will lead us to x to the minus 1. As opposed to here, what I'm going to do is I'm just going to write out what we actually have. So we have x times x, and then here we have x times x times x. Now two of them will cancel, and be careful, the answer here is not x, but you have an x on the bottom, and you have nothing on the top, so you're just going to have a placeholder of 1. So look what emerges. What emerges is when you have a negative exponent, you can change floors. So by that I mean move the numerator to the denominator or vice versa, and the exponent becomes positive. Okay, so one more time, taking the subtraction approach, we have 3 minus 5, and that will lead us to minus 2. Taking the expansion approach, you can see that 5 on the bottom and 3 on the top, you will be left, after you cancel, with just the 2 x's on the bottom. Okay, which makes sense, right? You had more on the bottom to start with. Again, change floors, change the sign. Okay, so that's what this generalization says, that if it's x to the power of negative m, that's the same as x to the positive m in the denominator. Okay, you can also see this as a pattern with the powers of 2. So if we start with a 2, you can see this is all a multiplication of 2. So if we're going this way, let's multiply. So this is 2, this is 4, this is 8, then this is going to be 16, and this is going to be 32. Okay, now let's walk back, and now we're going to divide. So 32, 16, 8, 4, 2, 1, just to pause, there's that 2 to the power of 0 being 1. We already learned that rule. Dividing that by 2, 1 divided by 2 is a half. And dividing a half by 2, that will be a quarter. And of course you can see that that is in fact coming from 1 over 2 to the 2, right? Change floors, change the sign. Change floors, change the sign of the exponent. So now you can see the pattern here. 1/2, 1/4, this is going to be 1/8, and this is going to be 1/16. And the 1/16 coming from 2 to the power of 4 in the denominator. Okay, so let's apply it to some actual questions. And here we are. And the first ones, we're just going to change the floor, change the sign. So we're going to send the 9 to the denominator, and the 2 becomes positive. And now we can actually evaluate it, which means find the numerical answer. So you have 1 over 81. Okay, now here, well, I'll show you the longer way quick. So what we're going to do is we're going to write this as 1 over 5 over 3, and then that became positive. Well, this means 1 divided by 5/3 squared. So I'm just going to rewrite it as that. So 1 divided by 5/3 squared. Well, you know how to divide fractions, right? Change the multiplication, and the second term takes the reciprocal. And so now what we have is 1 times 3/5 squared. The 1 times won't do anything, it disappears. And then don't forget to square both. Remember the rule from yesterday? If it's in the bracket, then the squared will apply to the numerator and the denominator. And so our final answer is going to be this. Now what we are interested in is the fact that you don't want to do this every time. What you want to notice is that what ended up happening is that the numerator came to the denominator, and the denominator came to the numerator, right? So you can just literally reciprocate them and change the sign. Change the floor, change the sign. That's what that says right there, okay? So, a couple more. Notice the difference here. We saw this before. Here, the rule applies only to the x, so we're going to have 5 times 1 over x. So we've sent the x to the bottom. And now simplifying this, the 5 is in the numerator and the x in the denominator. So that's that finished. This applies to the whole term. So both of these terms actually. And so you're going to have 1 over and then 5 to the x. So do note the difference. Okay, last one. A lot going on here, but we can do it. Okay, so again, remember from yesterday, the coefficients, they just get simplified. This is just a fraction, okay? So you have 9 over 12. That's going to be 3 over 4. Okay, so now we're going to subtract. So this is going to be x squared, because 4 minus 2. Now I'm just going to subtract everything first. Then be careful here. This is minus 4 minus minus 3. So this is actually going to be minus 1. And then the z is going to be minus 3 minus 4. So the z is going to be minus 7. Now in order for this to be fully simplified, anything with a negative exponent has to change floors and become positive. We don't like negative exponents as final answers. So the x squared is just going to stay where it is. The y is going to move down to the bottom, right? So it's like saying 1 over y, and z to the negative 7 is also going to move to the bottom and become positive 7. You don't need to write this 1 here. Doesn't do anything. Okay, so I hope that makes sense, and that's negative exponents for today. Bye.